and it is just like a lot of theory and a lot of definitions and a lot of equations. And most of it you have already studied in fluid dynamics. Okay. When did you study fluid dynamics?
Fluid dynamics
Yeah. You have not studied fluid
เรียน
dynamics?
แล้วไอ้นี่ไงก็เทอร์โมรวมกัน
ใช่แต่ผม
มันจบที่อะไรจบที่ไอ้เรื่อง
we don't cover the whole
the
Oh
half
gosh.
only half
Only half.
only fluid standard
Okay. Alright. So in this one as well, we are going to
Really
go
high.
convection.
เรื่องวิทยาดามิกเหรอ
You are from electrical mechanical manufacturing, right?
I think the furthest we go is Bernoulli equation.
Okay, it's fine. So we are going to understand types of convection, understand a few of the definition like velocity boundary layer, thermal boundary layer, laminar flow, turbulent flow, and derive some equations. So convection is of two types mainly, natural and forced. So we have talked about it in the very first chapter, the types of convection, right? So natural convection is when the heat transfer is happening naturally by convection, right? And forced convection is when you are using some device outside like a fan or a cooler, right, to increase the heat transfer by convection. So that will be your forced convection. Forced convection have another two parts, external and internal. So we are not going to cover everything, just a little bit of natural and forced convection. Okay. So you know convection happens when there is a fluid, right? Presence of a bulk fluid. When there is a presence of a bulk fluid, then only convection will happen. Conduction happens in the absence of a bulk fluid. Okay. we studied conduction, convection, radiation. Radiation we are going to study in our last class. These two are important. Among these two, this one is the most important. So we have spent 3 classes only studying conduction. Okay. Conduction and convection both happens in the presence of material, and radiation happens in the absence of material. Right. Convection will happen when there is a presence of a bulk fluid. Okay. There has to be a fluid. Conduction happens in the absence. Okay. Forced convection when you are using an external device to speed up. Okay. To speed up the heat transfer by convection. So if this is a plate, and this is the surface temperature of the plate, 50 degrees Celsius, you are using a fan, okay, and the air the fan is producing is 20 degrees Celsius. This is called free stream temperature. The velocity of the air is 3 meters per second. In this case, the heat transfer, of course, is by forced convection. Natural, when there is no external medium, that's a natural heat transfer. Now, heat transfer coefficient H is a very important quantity, right? In chapter 1, we studied how to calculate heat transfer by convection. Just a small, I think a few numericals only. So, in those numerical, H mostly is given, right? It is given because it is measured by experiment. You cannot measure it by doing numerical calculation. So your H is very difficult to measure. Why? Because it depends on so many things. Like I said there, mu, K, blah blah blah. Okay. So this depends on so many things. Among them is also flow of the fluid. So the flow can be of 2 types, laminar, I will explain this later, and turbulent. Okay. Laminar is still okay, turbulent flow is very unpredictable. Okay. So that's why the value of H